The next one is disposal. So, welcome to everyone. So, we are going to see the topic of disposal of municipal solid waste. So, in that, a major problem encountered in MSW, so methane, biogenic carbon dioxide, non-methane volatile components, nitrous oxide in smaller amount, nitrogen oxide, carbon monoxide. So landfill, what is landfill? Disposal of residual solid waste in the surface of solid waste surface of the solid soils of the earth. Sanitary landfills. Disposal of municipal solid waste designed and operated to minimize the public health and environmental impacts. So, what is a landfill site? A site for the disposal of solid waste in which refuse is buried between layers of dirt or clay so as to fill in or reclaim low-lying ground. So landfill gases are produced in landfills due to the anaerobic digestion by microbes. Energy recovery is possible in producing biogas and the generation of electricity. So next one is disposal option. So uncontrolled dumping or non-engineered disposal. First one. Second one is sanitary landfill and composting, incineration, gasification, refuse derived fuel, that is RDF, pyrolysis. These are the disposal options of municipal solid waste management. So next one is disposal site selection criteria. So technical site selection of municipal solid waste management, technical composition, existing practice, site location and technology impact, institutional responsible agencies, operate and manage, financial for implementation, operation and maintenance, social impact, and environmental initial and long-term risk. Next one is sanitary landfill. So the term landfill generally refers to an engineered deposit of waste either in pits or trenches on the surfaces. When the compared to uncontrolled tamping, engineered landfills are more likely to have pre-planned installation environmental, so monitoring and organized and trained workforce. So these are the some pictorial example of sanitary landfill. So we will see that this one is creating one by one, layer by layer. This one is the first layer. If the first layer is filled, which means then only open to and fill the second layer. And after that second layer, it moved on third layer and then fourth layer. So once entirely filled with this layer, they provide a gas vent pipe for the methane gas production, and also they are providing liners liners for the collection of leachate, and also it will prevent the groundwater affection. So because the if we are depositing the municipal solid waste management means the leachates will be formulated according to the liners. The leachates will not be accumulate with the groundwater because it will affect more dangerous groundwaters. So only we will provide a liner for the purpose of controlling in the leach problem. Okay. So this one is a this shows this daily refuse and undistributed ground and refuse compacted and covered. So next one is principle of sanitary landfills. The purpose of landfilling is to bury or alter the chemical composition of solid waste so that they do not pose any threat to environmental or public health. Landfills are not homogeneous and are usually made up of cells in which a discrete volume of waste is kept isolated from adjacent waste cells by a suitable barrier. So clay, which restricts and environmentally sound sanitary landfills comprise appropriated liners for protection of groundwater from the contaminated leachate, runoff controls, leachate collection, and treatment monitoring wells, and appropriate final cover design. So, and this is a schematic layout of sanitary landfills. Once the waste kept in this kind of areas, and then we will provide methane monitoring pipe, and then to once it is finished, we will finish the waste means we will provide a final cover, and also gas control to be provided, and then groundwater also monitoring pipe to be provided. These are the leacher control system, because leachate affecting the groundwater, so we will provide leachate controlling system. So these are the schematic layout of sanitary landfill. So next one is a life cycle of landfill. So there are five types of life cycle is there. So first one is planning phase, and then construction phase, and third one is operation phase. The operation phase will be maintained on 5 to 20 years, and the completed phase it will be kept on 20 to 100 years, and then final storage phase. So these are the life cycle of a sanitary landfill. So first of all, life cycle of sanitary landfill, we will see the planning phase. So this typically involve preliminary hydrogeological and geotechnical site investigation as a basis for actual design. So these are the planning phase. We will provide the planning for a sanitary phase. So next one is construction phase. So this involves earthwork, road and facility construction, preparation of liners and drains of the fill area. So next one is operation phase. So it will be 5 to 20 years. This phase has a high intensity of traffic, work at the in front of fill, operation of the environmental installation, and completion of finished sections. So these are the some schematic layout of operation phase. So next one is a completed phase. It will be kept. And the next one is a final storage phase. In this phase, the landfill is integrated into surrounding for other purpose and no longer to needs to special attention. So the next one is the landfill process. Site selection process and the consideration of landfill is for site include public opinion, traffic patterns and congestion, climate, zoning requirements, availability of cover material, and liners as well, height trees or buffer in the site of perimeter, historic buildings and enlarged species, wind, wetlands and site land environmental factors, speed limits, underpass limitation, load limits on the roadways, bridge capacities, and proximity of major roadways, haul distance, and hydraulics of debtors. These are the landfill process, and this one is a compacted soil of sanitary landfill. To it will show the wastage kept in cell by cell. Once the cell is filled with, after that we will move on next cell. So these are the compacted cellular structure of sanitary landfill. This one is a sectional view through the sanitary landfill and settling process of sanitary landfill. So first one is primary consolidation, and the next one is secondary consolidation, and the third one is decomposition process. So next one is a settling process. Primary consolidation. A substantial amount of settling occurs. The settlement is caused by the weight of waste layers. The movement of trucks, bulldozers, of mechanical compactors will also engage this process. Secondary compression. During the stage, the rate of settling is much lower than that in the primary consolidation stage, as the settling occurs through compression, which cannot be engaged. And next one is a decomposition. During the degradation process, the organic material is converted into gas and leachate. The settling rate during this stage increases compared to secondary compression stage and continues until all compostable organic matter is degraded. The settling rate, however, gradually decreases with the passage of time. So next one is biodegradable microbial degradation process, and the anaerobic degradation process undergoes the following stage. So first one is solid and complex dissolved organic components are hydrolyzed and fermented by the fermenters primarily to volatile fatty acids, alcohols, hydrogen, and carbon dioxide. Next one is methanogenic and then hydrophilic. So these are the enhancement of degradation, adding partially composed waste. So once the waste process is decomposition over means we will add partially composed waste, and then recirculation of leachate, slow increases in moisture, long period of gas production. So next one is advantages. So most and simple and economical, no costly plant, no need of separation of refuse, no residue byproduct completed method, environmental friendly. So next one is disadvantage, low lying depression or dumping site scare, continuous evolution for fuel gas dumping explosive, harmful non-biodegradable carbogenic chlorinated. So next one is site selection of sanitary landfill, access the site road and cell design and construction specific requirements design, cover material and land area, landfilling method, equipment requirements, heavy earth moving machinery, fire prevention, non-potable water outlet, cellular cell separation, litter control, drainage arrangement, unloading area. It will be kept on up to 30 meter. Production of underground water. So protection of underground water and gas recovery or prevention of gas movement, communication facilities, operational records, employees facilities, equipment maintenance, days and hours operation. These are the landfill liners and it's a pictorial example of landfill liners. Next one is landfill liners. So landfill liners used to design constructed to create a barrier between waste and the environmental and to drain the leachate to collection treatment facilities. This is done to prevent the uncontrolled release of leachate into the environment. So these are some example of types of liners. So this one is an example of geosynthetic clay liners, and these are the geosynthetic lines and the character of landfill liners. A landfill liners and the composite liners is low permeable barrier, lie down under engineered landfill sites. Liners retard migration of leachate and its toxicity constitution. Chipped or waste layers are used to support and insulate the liner. So next one is landfill liners, landfill geometry, embankments, excavation, remaining soil stored for covering, maximum compaction production test, a leachate drainage layer, 30 centimeter thickness made of filter gravel, components of base scaling sealing system. So municipal solid waste rules of 2000, mineral sealing liners, that is 3 layers of clay, 30 centimeter, hilly area. So next one is geosynthetic clay liner, impermeable barrier, bentonite clay, organic clay bonded two layers, used for most liners and sloping action, may be further reinforcement with an additional layer of HDPE. This is geosynthetic clay liner example, and landfill gas and leachate. Leachate and landfill gas comprise the major hazards associated with landfill, while leachate may contaminate the surrounding level, land and water. Landfill gas can be toxic and lead to global warming and explosion leading to human uh, catastrophe. Next one is leachate. Generation of leachate gas such as methane and CO2, creating bad odor and causing environmental pollution. Possibility of fire accident due to the CH4, that is the methane evolution, soil and groundwater pollution, attracting the flies and insects. And leachate management. These are steps of leachate management. First one is leachate collection system. Next one is leachate reduction, leachate evaporation, and then leachate disposal, leachate treatment. Okay, so thank you. We will see in next video to the leachate management. Thank you.